How's everyone doing? Oh, am I supposed to? Is this on?
No, it's not.
All right. Can you hear me?
No.
That's fine. I'll just talk loud. I'm on this thing, right?
If you're on that, it's going into the video. That's fine.
Well, that's all that really matters, right? As long as everyone can hear me in the room. What?
You're going to have to talk.
Just talk loud.
That microphone's just.
Okay. I can talk up. All right, so today we're going to talk about the anatomy of web client attacks. First, a little bit about me. My name is Jason Gillam, security consultant at Secure Ideas. I like to hack things. And by that, I really mean sort of the innovative problem-solving type of hacking. Also, breaking things is fun, too, as long as you have permission. I'm also an open source contributor. Before I got into the penetration testing side of things, I did a lot of software development. So now I use those skills to build tools to help me break into things. So it's kind of fun. Also of note, at the very bottom, probably the last word on there is probably the most important thing to know about me is I am a home brewer as well. So not really relevant to this talk, but. Okay, so why are we here? I spent a lot of time going, typical for me is I go from one location to another at a client site or working remotely with a client and do penetration testing. So I get exposed to a lot of different people and their different opinions of things and their different levels of understanding. And it came to my attention through this that there are some misconceptions out there about what some of the alphabet soup around web client attacks really means. And this is an area, I do various different types of penetration testing, but web pen testing is an area that I'm very interested in, more so than some of the others. So I spent a lot of time in this area, and so I thought I would put something together to help clear up some of this. It is a semi-technical talk, so I'll get into some of the details on how some of these things actually work and some of the issues with them. And there's more than what's just on that slide, too. So I'm going to talk about 3 different vulnerability classifications and then also some of the controls around those. The three are in the OWASP top 10. Has anybody not heard of OWASP? No hands went up. That's amazing. So OWASP is basically the go-to source for web-based security. We're talking about web applications. The 3 vulnerabilities that I'm going to talk about today are cross-site scripting, cross-site request forgery, and the unvalidated redirects. So, and I'll also talk about how these can be used together in order to actually take something that, maybe the risk was only at one level, and then when you combine 2 of these vulnerabilities together in the same environment, how the risk to that environment goes up significantly. So first, let's talk about cross-site scripting. It's number 3 on the OWASP top 10 list. Another quick fact about it is it's the cornerstone of a lot of phishing attacks. So when you get that email that you're not supposed to click on, that a lot of people click on anyway, that's often will contain a cross-site scripting vector on there. Or it will lead to a site that has a cross-site scripting vector on there. So good things about cross-site scripting is it's been around long enough now that we actually have preventative controls built into the browsers. So only to an extent, though. And then there's 3 flavors of cross-site scripting we need to worry about. So we have reflected. And I'm going to go into a little bit more detail on all this stuff in a moment. So there's reflected, which is basically you get a link, you click on it, and then something that was included in that link ends up coming back on the response on that page. You have stored, where a cross-site scripting payload is actually stored on a server somewhere, and it comes back to everybody who visits a particular page. And then you have DOM base, the document object model, where some JavaScript actually inserts the payload into the DOM. And that one's actually, the DOM base is becoming, it's not that it's becoming more common, it's already out there. It's becoming more discovered, I guess, of late, because that's one that's very hard to detect with the automated tools that we've been using for many years. So we are getting better at that. You pretty much, your best bet at detecting DOM-based cross-site scripting is actually through static analysis tools. Okay, some examples in the media. So one thing I did, I've been interested in doing some more, I guess, research on cross-site scripting. And near the beginning of this year, I set up one of those Google alerts where you basically put in your search terms, and every day in your inbox you get the results. And I put in the keywords cross-site scripting and XSS. And oddly, near the beginning of the year, the first time I presented this was at CarolinaCon, and I had been getting, on average, maybe 5 or 6 results a day, which doesn't seem that bad. But I've kept the alert up there, and in the last couple of months, I'm averaging much higher numbers. I don't know if there's an increase in awareness or cross-site scripting itself or what, but it seems to be more rampant than ever. Some of the big ones out there, we have, and this is just, cross-site scripting is most effective on sites where they get a lot of traffic, right? So IMDb, that gets quite a bit of traffic. Another area that we find a lot of cross-site scripting flaws recently is in WordPress plugins. Okay, WordPress itself usually is okay for the most part. We don't see lots and lots of issues with WordPress, like the core. But the plugins, oh, they just keep coming up. This one here, Yoast, Google Analytics. I can't remember how many installations there are of this one, but it's a very large number. It's a widely used plugin. So when something like that happens and it gets out there and becomes public knowledge, of course, all those websites running it have cross-site scripting flaws in their websites. Bugzilla is another one. I got a couple more here. I'll just read them a little bit. I know they're probably a little bit small. We have a couple of CVEs there. One's for IBM Rational Quality Manager, and the one right below it is SharePoint. SharePoint's actually been riddled with cross-site scripting flaws over the years. It's always had some. So, but this one here, all of these are 2015. They're all pretty recently discovered. The one at the bottom I thought was ironic. National Vulnerability Database vulnerable to cross-site scripting. So, and that was this week. So, let's talk a little bit more about what cross-site scripting is. And hopefully, if you're a little unsure of exactly what it is or how it works, I'll be able to help clear that up in the next couple of slides. So Wikipedia says, I'll just read this part. Cross-site scripting is a type of computer security vulnerability typically found in web applications. XSS enables attackers to inject client-side script into web pages viewed by other users. And that is pretty accurate. I'm pretty happy with that description. One thing that I will point out, though, is we say cross-site scripting all the time. That's what it's called. That's what it was called way back when. But in reality, it's a bit of a misnomer, because the term cross-site scripting kind of implies that something is going across from one site to another. But that's not always the case. In fact, it's often not the case. So I actually, when I hear the term cross-site scripting, I'm thinking browser script injection. That's the way I perceive this particular type of vulnerability. Because what we're trying to do is we're injecting some kind of a script into the browser page, and it's going to run for whoever the victim is. So what kind of script are we going to put in there? Probably JavaScript. That's the most common type of script that we can inject. VB script will also work on Internet Explorer, though. So there are cases where a particular defensive filter mechanism may be filtering out JavaScript payload, but an equivalent VB script payload might work. So that's just something to keep in mind, especially if you're on the defense. Well, I guess if you're on the defensive side, you want to be aware of this. But if you're doing a penetration test at some point, don't forget about that one. There are a lot of companies that standardize still on Internet Explorer. So if that's your target, you can make use of VBScript. So for browser script injection or cross-site scripting to work, we really need two components to it. First of all, we need the right context. You have to be able to inject the script into some location on the page where it's actually interpreted as a script, as something executable. And the second component, of course, is we need actual execution. It's possible to get script onto a page that's in a supposedly executable context, yet if it happens, after the page is processed, or if you end up with certain other, like just the order of things that happen, you might not actually have execution of that script. And I've actually found that in a lot of cases. Like sometimes you'll have JavaScript libraries that are loading other libraries that are loading other libraries, and you have this ripple effect, and it just depends on the order of how things are loaded and where they come in as to whether or not you might actually have execution of your injection flaw. So, point is, if you're doing this as a penetration test, you need to be able to come up with a proof of concept, something that actually shows that the injection is in an executable location and that it's executing. So how does it work? I'll go over the absolute basics here. This will just take a couple of moments. So, and I noticed the website here, Chaha. If you're in Charlotte and you're interested in hacking stuff, go to the Chaha or Charlotte Hackers website, because on a monthly basis, we get together, and Dave mentioned this earlier. We talk about hacking things and have a bit of a social hour as well, so it's pretty cool. But we have, OK, so you have a page. There's a parameter on there. This one's name equals Bob. OK, it gets passed in. And in the response, of course, Bob comes back and shows up on the page. So when you have cross-site scripting, this, again, is the most simplest of examples. We are able to add JavaScript onto that parameter, and then that JavaScript gets inserted on the page, and so it comes back. And what happens, of course, is, in this case here, we have an alert pop-up box. Comes up with the number 1 in it. Often we'll use, so this is basically a litmus test. This says, can we get injection that's actually executing? And although a pop-up box is really not that big a deal by itself, the reality is, of course, if you can get a pop-up box, you can do anything else you can do with JavaScript. So if you are in a position where you have to convince an executive or a senior manager that this pop-up box is dangerous enough that we got to go fix that flaw, you might want to look at doing something other than pop-up boxes, and I'll get to some examples later on. But it's really, hopefully, comes down to a conditioning that when they see this alert pop-up box, they recognize, OK, this is bad, even though the pop-up box itself isn't. You'll also notice that I used just one by itself. I didn't put a string quote in there. Sometimes you'll see quotes, XSS. I'll often, when I'm doing a test, just do the number 1 by itself. Because it's not a string, I don't have to worry about whether or not the quotes are filtered. So that's why I did it that way. So JavaScript, brief history. I won't spend all day on this. But basically, JavaScript's been around for about 20 years. Just about as long as the web, almost. So it's been around for a long time. The other date on this particular slide that's important to note is the one at the bottom, 2005. So that's when that term AJAX was coined. So everyone's heard about AJAX. This is your dynamic XML over dynamic JavaScript and XML. So basically, we have a page. We have some piece of JavaScript on that page that's going to make a call out to somewhere else and pull information in, and then dynamically update part of the page instead of the whole thing, right? It's supposed to make everything faster and flashier and more dynamic. The reality there, though, I'll point out, and I don't have the exact date where it was first used, but web remoting was around before the term AJAX was actually coined. So this thing that we call HTML5, where the web's all dynamic, it's actually been around, or parts of it have been around for much, much longer, pretty much as long as we've been using JavaScript, which is a very long time. So there's a lot of vulnerabilities floating out there that we still haven't found. So what's it good for? What can we do with JavaScript? Are there any JavaScript developers in the room? You probably know better than I do. Okay, got a couple. So you can do a lot of stuff with JavaScript. Here's just a few examples. You can manipulate the page itself. You can read headers and cookies, which is kind of cool, especially if it's a session cookie or something else that has some sensitive information in there. You can do some level of key logging as well. You have some level of control over the media devices that are attached to your laptop, the camera. You can do some streaming. You can take some screenshots. You can have a certain degree of access over the microphone, speakers. So there's a bunch of things that we can do with it. So now, if you've been listening so far and this is not really familiar to you, then the paranoia might be setting in a little bit. You can do a lot of things with cross-site scripting, and it seems to be all over the place. It's been around for a long time. Why isn't the entire internet compromised by cross-site scripting flaws? And the reason why it isn't, primarily, is this thing called same origin policy. Okay? So the same origin policy, before I get into the policy itself, let's define what we mean by an origin. Same origin policy is considers an origin to be the combination of your protocol, your host, and your port. So if any of those are different, any component of the origin is different, then you're talking about a different origin, which means, for example, in this case here, we have Chaha on port 8080. If you also had, let's say you had HTTPS version running on, I don't know, we'll just say port 443, then that's a completely different origin, even though it's the same host. So what the policy does, it's a browser-enforced security feature. So the browsers all have this built in on how they do things. And it basically makes sure that code that's running in the document on one page is not allowed to interact with the document from a different origin, any document from a different origin. It can interact with documents on the same origin. So that's where you still get your dynamic HTML and everything working there. But it can't, in general, go out and fetch content from somewhere else and see it and interact with it and get cookies from it and all of that. If it could, then the whole internet would probably be compromised by cross-site scripting. So in general, this is a pretty good control, except once in a while we have other problems that crop up. This happened this year, that Internet Explorer had something that was pitched as a universal cross-site scripting flaw, which wasn't actually a universal cross-site scripting flaw at all. What it was a same origin policy bypass. So this policy is in place. It's supposed to protect us from scripts being able to just run anywhere and access documents anywhere. And Internet Explorer, the latest version at the time when it was announced, was vulnerable to this same origin policy bypass. And I played around with this. They had a proof of concept out there for this thing. And in the proof of concept, you had to, I think you had to click on a couple of different things. So it made it look like it really wasn't that big a deal because you'd probably notice pop-ups and, hey, I have to click here. But I actually tinkered with it a bit more and was able to get a working proof of concept that required no user interaction at all for the same origin bypass, which means anybody who would be attacked by this running a vulnerable version of Internet Explorer would be able to essentially pull their session cookies. So I'll use that as probably one of the more critical examples. from any other website they visited in the same browser. So, some cool stuff there. And no, I didn't publish that. It's not something I really want running around rampant on the internet for script kiddies to get a hold of. So there are some exceptions to the same origin policy. The first one is built into HTML itself. There are certain things that don't use the same origin policy. For example, the script tag, when it loads a source, you can load scripts from other resources. It doesn't have to be the same origin, and those scripts will still run. I mean, that's how we get, if you look at, for example, jQuery libraries and other things like that, they're often hosted somewhere else, and we just bring them into the pages. And there's nothing special you have to do for that, because that's a built-into HTML itself, where it doesn't make use of the same origin policy. The other one is something called the CORS, cross-origin resource sharing. And this is an area that I've found that's a little fuzzy to some people. Is it anybody here not really sure what it is? Yeah, I've seen a few hands go up. Basically, let me go on to the next slide, and I'll explain what it is. So the CORS, or cross-origin resource sharing, is another type of policy. It's sort of an override to the same origin policy, but just with respect to JavaScript calls. So when you're doing your sort of your AJAX type stuff. So it's what makes HTML5 mashup type code actually work. It gets us away from having to load content into iframes. So you can actually get content from somewhere else onto your page, as long as it conforms to the CORS policy. So the policy itself it's defined on the server. And that would be the server hosting the content that you want to pull onto your site. And it's the browser that actually enforces it. So if you look at the spec for this, and I don't have the spec number here, but there is no requirement at all for the server to actually obey its own policy. So if a browser makes a request for some content and it's actually outside of the policy, that request, it still may actually return that content. It's up to the browser to then put that code into its exception block instead of the success block. And I've actually played around with that, and that's exactly what happens in some cases. I would imagine each server is probably treated differently. There might be some that obey their own policies, but so far I haven't had much luck with that. So a little illustration of how this actually works. If we have two sites, so we have foo, that's the site that you're visiting, and then we have this other site, bar, that has the CORS policy on it. What's going to happen is when you make that XML HTTP request object inside of JavaScript, and when you make the request with that, the browser is going to add that origin header onto it. You can go ahead and look inside of your intercepting proxy, and you'll see that just show up. It's not something you have control over. The header just goes there. When the server, any server that supports CORS, sees that header, it will reply with its policy, whatever is defined on there. And so we have down in the bottom right-hand corner there, you can see some example headers. The one at the top is the most common one that we'll see. Access control allow origin. Okay. If you're using scanning tools, I'll use burp because that's the tool that I use a lot. It actually has a finding that pops up sometimes where the access control allow origin is star, and it calls that out as an issue. The reality is, at least I experimented with several browsers, that's not an issue. Because the third header on there, the one at the bottom, access control allow credentials, if that's set, that means that a request can be made for content where the session cookies will also be sent. Well, any cookies will be sent. That's what that means. Allow credentials. What they mean is allow cookies. So in that case, we're making our XML HTTP request to a different origin. And as long as the origin is in that list, the access control allow origin list, if the access control allow credentials is also set to true, then what will happen is you can, the request that was put together on foo is going to actually, the browser will send cookies to bar in that case as well, except if the origin is star. So they were a little smart on how they implemented that. If you say that the access control allow origin is star, then the allow credentials gets disregarded. So that's actually not as big an issue. What is a bigger issue is cases where you have a site that's pulling content from somewhere, and if that site has, basically what happens is any vulnerabilities on foo become vulnerabilities of bar as well, because you've basically extended the origin of bar through its CORS policy. That makes sense? I'll have a little bit more on that in a second. So going back to cross-site scripting and our pop-up boxes, if you're interested in trying to figure out, okay, well, what are some other options? I know I had a list up there earlier. Has everyone heard of Beef, the browser exploitation framework? If you haven't heard of Beef or played around with Beef, then I recommend that you do. It's especially if you're getting into cross-site scripting. If you're doing like awareness training for phishing in your company, it's also something that you want to play around with there. Basically, what it does is it creates zombies. That's what, that funny yellow sign there, that's actually supposed to be a zombie caution sign. That's what I was told anyway. So it creates zombie browsers, and then you can basically send commands to them, kind of like a command and control sort of thing. And that's available on, you'll find that on Caldi and Samurai Web Testing Framework and other places, or you can just install it. It's got some pretty cool functionality. I'm not going to go through all that here. It'll take a while. I want to move on to a couple of other things. So redirects and forwards. So far, all I've talked about is cross-site scripting, but there are other vulnerabilities that we can find in browser code. One of them is unvalidated redirects and forwards. So redirects and forwards by themselves, that's a normal part of how the web works. We're always forwarding pages to other pages. Really common one to see, and I'll use this as an example in a moment, is you go to a website and you get redirected to the login page. Okay, it automatically is trying to help you out. It's not going to make you click on another link if it doesn't have to. It'll just say, okay, well, you're not logged in. I'm going to redirect you to the login page. And in addition to that, we'll redirect you to the login page. I will also, let's just look at the example here. I will also keep track of the URL that you first clicked on, so that once you've logged in, I can bring you back to where you were trying to go in the first place. Right? So that's basically what we're doing there with a redirect. Now, when we have, so that's normal. We see this all over the place. This is not a vulnerability by itself. What is a vulnerability is unvalidated redirects and forwards. So in this case here, we're passing in a URL that's not actually part of the site. It's to somewhere dangerous and evil. And what's going to happen, of course, is the user will get, if they click on this link, they'll get the login box. They'll log in, and then they'll end up over at evilhacksaw.org. And I'm trying to think of attack scenarios where this is particularly bad. And I'll pick on the login form because that's my favorite place to find this. We have something that I call the evil twin login. So what we can do is take the original login page and replicate it somewhere else, somewhere that we control. And the user experience in this case is, first they're going to get the, they'll click on something, they'll see the login, they'll log in, and then they'll see the login again. It's like, okay, well, maybe I typed it wrong or something, right? So they'll retype in their username and password, and then they'll go back to wherever it is they were supposed to go in the first place. What's happened, of course, underneath the covers is that second time they've logged in, their URL changed. So now they're actually sitting on evilhacksaw.org and logged in with their credentials and gave them to me. Great place to find this sort of thing is on single sign-on solutions. Okay, you probably won't find that too much on the big enterprise solutions that are sold out there now. But you know, sometimes we find single sign-on solutions that are homegrown, and users are accustomed to logging in on a fairly regular basis. The same screen pops up all the time, so if you can make use of that during a pen test, it's one way to gather credentials pretty quickly. So, you can combine the unvalidated redirects with cross-site scripting attacks, or if you can, then things might get a little more interesting. You have potentially more convincing phishing links. So you can bring them to a server that that's part of their organization first, and use the redirect flaw in that to get them onto some other server that has a cross-site scripting flaw. So they'll see the link that they trust, and they'll click it. You may also be able to make use of this to help facilitate running a cross-site scripting payload inside of the authenticated space. And that really goes to, you know, can you add it onto that login URL so that the person logs in and then they activate the cross-site scripting flaw afterwards. All right. So redirects and forwards. The next one, the last one that we're going to talk about, is cross-site request forgery. CSRF, sometimes you'll see it, XSRF. Basically, this is a type of vulnerability that's, it's, I think, become, there's a lot more awareness around it now. I'm seeing in my pen tests, a lot of people will have controls for it built in to prevent it, which is good to see. But basically, this has been around for a long time. Cross-site request forgery has been around as long as browsers have basically had tabs. So it takes advantage of the fact that your browser is keeping track of multiple sessions at the same time. Okay, so a cross-site request is a very normal part of the way the web works. We do this sort of thing all the time, right? We have cases where we have content that's being put into an iframe, or we have script tags or images. These are all things where there's a request that goes out to some other site, or can go out to another site and pull content into your page. And it's set up that way. So naturally, we want to look at, as you know, hackers, we want to look at what we can do to take advantage of what's normal and see if we can do something a little less normal with it. So the forgery really begins with the sessions, with the cookies. Okay? So what we need, and specifically, I guess what we're really talking about here is not the fact that there's cookies, but the fact that the cookies, or session cookies, are often protecting functionality that's sensitive in nature. So that could be your email, it could be banking, maybe healthcare records, or you know, a lot of the other stuff that's on the web, anything that you log into. The second component that we need for cross-site request forgery to work is predictability. And what I mean by that is we're trying to run a function, and are the parameters for that function something that an attacker can guess? Because in general, unless it's combined with another vulnerability, your cross-site scripting is, or your cross-site request forgery is not going to result in the attacker actually seeing the results of the requests that are forged. That request is made from the victim's browser, and it goes out to another tab. So an example might be, let's say I'm browsing, let's say I've logged into my online banking account, wherever it is. And then I've left that tab, and I'm doing something else. Right? We all multitask. We got, I don't know about you guys, sometimes I have, I don't know, 20 or 30 browser tabs open at the same time, which is really bad practice. Makes you kind of open to this sort of thing a little bit more, but we all do it. And so I go to another one, I go to a site that's been compromised. And inside that site, an attacker has put together a vector where they have, let's say it's an iframe call or an image call, back to a function on my online banking. So maybe it's a post or a get that transfers funds over to their account. What's going to happen, of course, is the browser's going to see that call. It's going to say, OK, well, it's coming from you. You're already logged in. I'm going to go ahead and send any cookies that belong to that origin that I'm sending them to. And basically, it gets processed behind the scenes. The victim never sees the response. Their browser does, but we can craft it so that they don't. And as far as the browser is concerned, it's a normal function. It was supposed to be that way. Some key points about cross-site request forgery. You don't need any scripting at all to do a cross-site request forgery attack. I already said you can just put that inside of a source tag for like an iframe or an image. So there's ways to construct cross-site request forgery with no scripting at all. It also is not subject to the same origin policy because we can make use of those mechanisms that I just mentioned that I previously said. These things are not part of the same origin policy. Same origin policy does not apply. So. Now, there are situations where you might have cross-site scripting and cross-site request forgery combined together. And those can be a lot of fun. Really useful when you have the cross-site scripting and the cross-site request forgery on the same, within the same origin. When you think about it, if you can inject a script and you have predictable, sensitive functionality on there, then you can even bypass most cross-site request forgery controls. So something that previously might have been considered not vulnerable all of a sudden becomes vulnerable, because if I can run a script on there, that means I can make one call, let's say it's protected by a random token. I can make a call, get the random token, resubmit that random token with the sensitive function data, and lo and behold, I'm able to execute that function from within my cross-site scripting payload. The other place where cross-site scripting and cross-site request forgery combined are pretty cool is when you have a CORS policy set up. So I mentioned this before. If I have a CORS policy on a server that allows certain other servers to connect to it, then vulnerabilities, cross-site scripting vulnerabilities on those other servers basically become my problem as well. So be very careful. Really, the takeaway from that is be very careful with your CORS policies. Don't accept origins that you can't trust. Right. So another thing, I mentioned beef before. Go back to beef and take a look at the list of exploits on there, and you'll probably notice I've put red boxes around several of them here, and this is just a partial list. Cross-site request forgery shows up a lot. It's a very common vector, very common for if you can execute cross-site scripting flaws to make use of that to get elevated privileges or create a new account, new admin account or something like that. You see a lot of these on devices, on your routers, and it's basically just taking advantage of these weaknesses together in a web interface. So, and I have one last little bit here, one last combination. We have cross-site request forgery along with an unvalidated redirect. So cross-site request forgery, I mentioned, that's when you have multiple tabs open. Remember how I said I had to log into my online banking first, and then if I then went to a cross-site request a page with a cross-site request forgery flaw on it, it would be executed against that and send the cookies and activate the function. So what a unvalidated redirect allows you to do is, and again, I'm picking on the login one, is if you have that, again, on a part of a login functionality, which is extremely common to have it, then we're in a situation where we can ensure that the user actually logs in. They authenticate first. We can send them a phishing link. They authenticate. Then the cross-site request forgery flaw gets activated. We transfer funds to ourselves, and and then the victim is unaware of anything that happened because they get redirected back to where they're supposed to be afterwards. So from their perspective, all they really see is it kind of flickered somewhere, and then I came back to where I was supposed to be anyway, so it's probably no big deal. So, that make sense? Yeah. So there's some different ways you can combine things. I actually put together this little sort of cheat sheet to summarize everything that we talked about today. I can make this available afterwards if anyone wants it. And that's basically it. That's all I have. So one thing just like Dave, I do have some giveaways here. So I don't know if we have. Do you guys have questions? Let's ask the questions for the giveaways first, and then I'll come back and.
So, because you were mentioning like IMDb, like right at the beginning.
Yes.
Cross-site scripting vulnerability.
Yep.
I guess I'm not understanding. So basically, the IMDb server was spitting out these cross-site scripting things, or it was vulnerable to someone like clicking on an email, like a phishing email, and that's how IMDb became vulnerable?
So I'm not sure exactly where the flaw was in this case for IMDb.
Well, I mean,
but
in general, I'm just trying to understand, does the actual website needs to be compromised in order for cross-site scripting to happen, or
yes,
did
but
they just use a compromised library, and that's how?
oh, okay, yeah. So it could be a compromised library, or it could be a flaw in how the website itself is designed. So where we often run into this is stored cross-site scripting, where it's maybe a comment field or something along those lines. That seems like that might be the case for the IMDb. So if there's somewhere in there where, and I have no idea if this is where the flaw was. I'm just guessing. But let's say I was able to comment on a particular movie, or an actor or something like that. Then if I could actually put script tags into that comment, and those script tags get executed to everyone else who views my comment, then what happens is it's not like I've compromised the server itself. I've compromised the content on the website.
On the specific page.
On that specific page, right. And so then it becomes a problem, because everybody who visits that, now they have my malicious code running inside their browser. So. So how do you? So the question I think is how do you determine if a cross-site? No, you're talking about the redirects. Is there any way to identify whether or not it's a legitimate login? Really, the only thing is the browser itself. So what we usually do is we'll recommend, if you're implementing, it's a flaw in the implementation of the single sign-on. So really the fix is to fix that flaw, and then people don't have to worry about it. But as an individual running across this, if you're logging into something, just check the URL bar and make sure that you're actually logging into what you think you're logging into. Because it's really easy for me to take the HTML content off of any login page and replicate that on my own server. Right? I can just, it's kind of an exercise in copy and paste. So. Cross-site request forgery. That one can't be, the user usually is completely unaware. So there's not anything that you can do as an individual to protect against that. It's up to the organization, and the onus usually falls on the organization that's hosting that to ensure that that they don't have open cross-site request forgery flaws on there, because that's going to impact them financially most likely, or from a reputational standpoint to have something like that on there. Yeah, so if you're looking at ways to protect against it, go to, again, I mentioned at the beginning OWASP. So if you go to the OWASP website and look up cross-site request forgery defenses or controls, they have a pretty good description on there on the types of things that you can put in place to prevent that in your own code. It's a relatively easy fix for most people, which is basically you have a token inside of your form that's random in nature, and then you check that token once a form's been submitted to make sure that it matches what was in the hidden field. And the reason is because we've gotten away. Remember, I said predictability is key to making cross-site request forgery work. So all you need to do is make something that's not predictable to an attacker, and you have a control in place that will mitigate most cross-site request forgery attacks. So, anything else? All right. I'll be in and around all day, so if you have any other questions about web stuff or anything else, or homebrewing even, let me know. Let's do our giveaways.
You have a question?
Huh?
Do you have